Okay, so for everybody, I mean not for everybody, primarily for Surbi, this is your first class with us, so there are a couple of things that I would want you to be aware of. That is, when we are in the class, you don't have to worry about taking notes, because everything that I'm doing is getting recorded right now. It's only me and the board, you guys are not getting recorded, okay? So if you are keeping a video on, be sure that you are not going anywhere, okay? So you will have a video of the class that you can watch later and make your own notes with your own comfort, okay?
Okay.
So that way you are relieved from the pressure of making your notes while we are in the class. And what it means is that the time that you are saving by not making notes, you can use that for following the concepts and arguing with me, debating with me, asking me to explain things if that something is not clear to you, okay? So feel comfortable to ask questions. There is nothing wrong in asking questions, okay? Yeah? Alright. So I will take 10 more seconds and we'll get started. So I don't know if Ariane is coming or not. If she does, she has not heard. Alright. So we are starting with so we have almost everybody except Ariyahi. So we are starting with a unit called logarithms. Logarithms, who all has come across this in the past? And whatever you know, I mean, please feel free to share. What is your understanding of logarithms or logs? Okay, I don't know if I'm pronouncing it right. Can somebody help me pronounce it right? It is called logarithms or logarithms, whatever it is. The spelling goes like this. Logarithm. Have you heard about it? Anybody? No? Wonderful, that's a great news. Okay, how about Surbi? Have you come across this beta? Logarithms?
No, not yet.
Okay, that's a good news. How about Bhavish and Vasundhara? No? That's a wonderful news. Sana, Visali? Nobody has come across logarithms, is it?
No, sir. Not me.
Awesome, that makes me super happy. See, now I can teach you guys whatever I feel like and nobody can catch me going wrong. And Ifsa, there is one thing that I would suggest, don't read what is there on the table. Kids are creating a real mess, trust me. They have written all good and bad things on the table. Don't read them, okay? I'm feeling ashamed of what is written on the table. I have to clean it up, okay? So, logarithms. Now, before I start teaching logarithms, let me spend 30 more seconds to pronounce it right. Otherwise, no, I will sound stupid. Let's see what Google says, how to pronounce this word, logarithms. Just a second, okay? I am trying to deal with my hard, strong Indian accent. Logarithm. That's how it is pronounced, okay?
Logarithm.
Okay, so now you guys will not say that my teacher has a strong accent. I was saying it okay. Logarithm, okay? Now, what is logarithm and why do we need to learn this? First, try to understand some basic building blocks of logarithm. And I will take you guys back to the concept of exponents. If I have 3 to the power, let's say 3 to the power 3. Can somebody tell me how much it will be?
27.
27? 3 to the power 3 is nothing but 3 into 3 into 3 is 27. If I say 2 to the power 4, how much that will be?
16.
2 into 2 into 2 into 2. That makes it 2 into 2, 4, 2 to 8, into 2, 16, like it was said. Okay, so this is exponents. Everybody knows about it, right? Surbi and I will call your name little more often today because this is your first class.
Okay.
Don't feel that I'm trying to put you on the spot. For every child gets victimized by me in their first class, because I'm just trying to get a sense of whether I'm making sense. Am I speaking okay? Am I speaking very fast or not? Okay. So they are the exponents, basic understanding of exponents that we have talked about. Now, there is other way of looking at it, and that method is called logarithms. So here, if you look at this number, I'm deleting this part and writing it here as 16. I can write this in a different way, saying log of 16 base 2 equals 4. Same way in this case, I can say log of 27 base 3 equals 3. So now I should try drawing a correlation between these two that you see here. This became log of 27 base 3 equals 3, and this became log of 16 base 2 equals 4. Spend 30 seconds to read this and see what is the corresponding interpretation in terms of log. Look at this and relate with this logarithmic definition or explanation to see what is happening here. When I have 3 to the power 3 equals 27, or 27 is 3 to the power 3. So 27, if I take 3 as a base, this has this many powers to get to this. 16, what did I do here? 2 to the power 4 is equal to 16. So what I'm saying is, if I get log of 16 base 2, my answer is 4. If I get log of 27 base 3, I get 3. And you guys must be thinking, what is the big deal about it? This is, so far we always talk about numbers basing 10. If you are looking at any number that is around us, those numbers are always keeping 10 as a base. Here, log gives you a flexibility of changing your base. If you look at this one, you are trying to relate 16 keeping base as 2. Here you are trying to relate to 27 keeping base as 3. So tomorrow if somebody says find out log of 216 base 6, how much that would be? And what you will do is, okay, 6 to the power what? 6 to the power what will give me 216. And once you get that value of x, that is what will come here. So here if you say 3 to the power 3, this 3 is coming here. When you saw log of 16 base 2, you got 4 here. So basically 2 to the power 4 gives you 16. So here you don't know what is the value of x, meaning 6 to the power what will give me this. So basically it's a method that is used for doing more scientific calculations where you keep changing the base against which you are trying to evaluate a number, and logarithms give you that ability for doing so. Yes, Dishali.
So log is just basically x?
No, log, see, if you read this one, okay, read this like a pure simple English. To get 216 with a base of 6, what is my value? Meaning, if you read it reverse, 6 to the power what will be equal to 216. So this is an extension of what we know as part of exponents. So 6 to the power what will give me this number. If I am talking about, let's say finding out log of any number, let's say 125, okay, with a base of 5. So I'm saying, and I don't know what is that value, let's say that is y. So we are trying to find out 5 to what power will give me this value. Does it sound okay or not yet?
So the
yeah.
5 goes in the subscript.
I'm sorry, what?
So the 5 and it goes subscript. Like does it go in the subscript?
Yeah, so this 5 is your base. So if you think of, visualize this like an exponent, any number, let's say if you're trying to find out log of, let's say 512 with a base of 3. And what will be the value of this? So when you guys continue learning it further, you will come across log tables. Log tables are nothing but the value of different numbers with a base of 10. Okay. So here we are looking at the base of 3. If I ever say find out log of 121, if I don't put any number, default is 10. So if you have to find out the value of this, you have to figure out 10 to the power what will be equal to 121. That will be your interpretation from this. So once you find out the value of x, that will be the final value that you will have. Ananya also has joined, and I'm pretty sure I'm getting everybody confused right now. And this confusion will be knocked off with some practice. So let's hear Dishali first. Yes, Beta, go ahead.
So I had a question about, so the base can be in perfect squares or can it be decimals?
No, base has to be a natural number and it has to be a positive number and greater than 1.
Okay.
So now look at this situation, okay? Let's say, let's muddle the water a little bit here. Let's say if I say log of, find out the log of or logarithmic value of 121 with a base of 1. Okay?
Yeah.
If I'm saying find out the log value of 121 with a base of 1. So based on whatever I have told you guys, what it means is, let's say this is equal to y. After finding out the log value of this with a base of 1, my value is y. So what we are essentially saying is 1 to the power y equal to 121. And this is an impossible event. You will never be able to get to this. 1 to the power anything doesn't get you more than 1. Is that a fair statement? Is it making sense, Beta?
Yeah.
Yeah? Similarly, if I say I want to play with this, meaning I'm trying to find out a log of a number, let's say 5 only, with a base of 0.5. Okay? Ananya, are you able to follow me? I know you joined a little late. So far okay? Anika okay? Datta okay? Bhavish okay? Bhavish is not okay. It's okay? Alright. So let me keep it clean so that it doesn't bother you very much. So I'm saying that your teacher is kind of trying to muddle the water unnecessarily and trying to show his expertise to you guys. Okay? And he's saying, okay, I want to find out log of, let's say 6 with a base of 0.5. Okay? And how much is this? We are trying to find this out. So whatever we have to find out, whatever is not known, we get tempted to put that as a value x, right? Let's say this much comes out to be x, and once we find out the value of x, we are good. So if I am trying to find this out, this value of x, based on the basic definition of log, what it's saying is this to the power this will be equal to this. Now look at this, 0.5 to the power x will be equal to 6. Can we ever achieve this? Answer is no. Now look at it. If I am talking about 0.5 to the power 1, how much is that? 0.5. If I am talking about 0.5 to the power 2, it is 0.5 into 0.5,
So that's
0.25. If I am talking about 0.5 to the power 3, I am talking about 0.5 into 0.5 into 0.5. That is 0.125. So with every increase of x, my value is decreasing. So if I have base smaller than 1, I don't have a future to it in terms of log. Yeah, because with every increase of the power, you are actually decreasing. So 0.5 to any power will never get you to a number more than 1. It will keep on decreasing actually. Is it sounding okay to everybody? Dishali, Vasundhara, Myra?
Yeah, I got it.
Yeah? So this becomes the rule of thumb for us. That if you are talking about logarithms, your base has to be a number, it has to be a natural number. Meaning you cannot say, okay, I have to find out log of 21 base 0.21 or 1.31. This just creates a mess. You will always say, this has to be a natural number. My base of the log has to be a natural number and has to be greater than 1. 1 also is not acceptable, even if it's a natural number. And so one is, it has to be a natural number greater than 1, and it cannot be, I think one statement is enough. It has to be a natural number and greater than 1. If you are putting base as anything less than 1, no matter how many powers you add, you will never be able to get to any this thing. And the second thing is, there are two rules that we are defining here. First rule was, if I have, let me put a generic form of it. So if I'm talking about finding out log of A with a base B, there are certain rules that we have to follow. A must, not A, B must be a natural number and greater than 1. That is first rule. Now second rule, this A, the number for which we are trying to find out the log, this A should not be negative. We never find out log of a negative number. Think about it. If let's say I'm talking about find out log of -2 base 3. Okay? And let's say that is x. So based on basic interpretation from this, 3 to the power x equals -2. This number is positive. To any power will never give me a negative number. So this becomes the second rule of logs that we have to follow. If I summarize this, log is a way to find the value of a number with a different base, and that follows certain rules. The first rule of thumb is, the base has to be a number greater than 1 and must be a natural number. And second thing is, A must be positive. I'm not saying that A has to be natural number only. You can have log of 0.5 base 2, that is still okay. 2 to some power will give us 0.5 one day. How much is that power? That we'll figure out. If we can do it manually, wonderful. If not, calculator will help us with that. But remember this, this number cannot be negative. If you are ever talking about finding out log of a negative number, that is the last thing that you would want to do on a given day. Yes, Dishali.
Wait, why can't it be a negative?
I will give that example one more time. So let's say, and I'll pick up some easy example, okay? If I'm trying to find out log of, so I have two of the markers out of life. Let me throw that first. And everybody got the question that Disali is asking, right? Disali is challenging the teacher, saying, okay, why are you forcing me to believe that I cannot find a log of a negative number? Yeah? Surbi, Anika, Bhavish, Ananya, Maya, everybody got that question, right? Vasundhara, Anita, Sana, okay? Sana has been very quiet. So far, okay, beta? Yeah, okay. Now, see, when I don't hear back from you guys, that gets me worried. I want you guys to fight and argue with me, put me on the spot, but don't assume that everything that I'm saying is always right. Many times it has happened that one of you have corrected me also. So I do go wrong. Please participate in that conversation and try proving me wrong whenever you get an opportunity. Okay? So now, what Disali is saying is, why it is not possible. Okay? So I'm forcing myself to believe that, okay, I can still find out log of minus 4 base 2. Because 2 is a legitimate base. It is greater than 1. It's a natural number. So no problem. Right, Ipsha? You're okay with me?
Yeah.
So I'm forcing myself to believe that, okay, I can still find out the value of this negative number. I mean, I can find out the log of minus 4 base 2. So let's assume that I can get that. Let's say that is equal to x. So going by the basic definition of log, it says 2 to the power x will give me minus 4. Now the biggest dilemma we have is, how do I get to this? My base is positive. If I do power 1, I will get 2 to the power 1, I will get 2. 2 to the power 2, I will get 4. 2 to the power 3, I will get 8. 2 to the power 1 by 2, I will get 1.414. 2 to the power 1 by 3, cube root of 3 will give me some value. But every value that I am getting, since I am talking about a power to a positive number, I can get a small number, as small as possible. If I am talking about 2 to the power 1 by 30, meaning 30th root of 2, I will still get a positive number. But I am never able to get a negative sign against it. Am I making sense? Dishali?
Yes, sir.
Okay. Now, let's play with this a little bit more. I'm still not convinced. I'm thinking that no, I think this is possible. How about this? If I put this, okay, 2 to the power x equals minus 4. Okay. How about putting power itself as negative? So let me say 2 to the power minus 5. Will I not get something negative? Let's see what happens. 2 to the power minus 5 is nothing but 1 over 2 to the power 5. That means 1 over 2 to the power 5 is 2 to the 4 to the 8 to the 16 to 32. I will still get a number which is positive. How much, whatever that be. Yeah? So all the tricks and techniques that I tried applying to convince myself that I can get a negative number is not working. Do you guys think the same? If so, thinking the same, and she is saying, don't ask me again, I am convinced. How about everybody else? Surbi, I know this is your first day, and I hope this is not a ride. Yeah? Make sense? Okay, how about Disali? Yep, Disali, go ahead.
So what would be a perfect statement to like the result?
I'm sorry?
So what would it result in?
So, this is your condition. You are saying that I can find out the log of any number, but not a negative one. That is the precondition. So, like, you know, if you give me the area, a formula for finding out the volume of a sphere, I can find out the volume of a sphere of any size, be it a small radius one, be it a huge radius one. I can find out the volume of the entire earth, but I cannot find out the volume of a cube, even if that is a tiny one, using the formula for volume of sphere. and I know I'm giving a wrong analogy here, but the point that I'm trying to make is logarithm works perfectly fine within the constraints, and those constraints are your base cannot be a number smaller than 1, okay, and it must be a natural number, and you cannot find a logarithm for any number which is negative.
Okay.
Yeah. Now let's explain this a little bit more. Can I have, and trust me, I'll be dry honest with you guys. I am getting this idea while I'm talking to you guys. Can I find a log of, let's say, 4 with a base which is negative? Let's see if that is possible. Can I have a base of negative? Mostly all the rule books say that you cannot, it has to be greater than 1, but let's see if this is possible. I'm just exploring it while we are talking, okay? Now, let's say this has a value, meaning if I have a base of a negative, it's a natural number, but a negative number. No, it's not a natural number, it's a whole number basically. What I'm saying. If you look at the number line, I'm sorry if I'm taking you guys back in history. 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. All the numbers above 0, these are called natural numbers. Include 0 into it, called whole number. Everything together is called integers. So if I am talking about minus 2, I'm not talking about whole numbers or integers, or natural numbers, I'm talking about integers. Okay. So I was just correcting myself. I said this is a natural number or whole number. That is not correct. And if that helps you guys recall that number line, wonderful. So coming to this. Datta, are you with me so far, Datta?
Yeah.
Okay. So here, I'm trying to figure out, can I have a base of negative number or integer to, in a log situation? Let's see. If I go by this definition, minus 2 to the power x will be equal to 4. So, minus 2 to the power 2 gives me minus 2 into minus 2, that will be 4. So this is technically possible, okay? Technically this is possible with the example that we are seeing, but may not be true always. So you would want to refrain from using a negative number as a base, but is it a strict no? Is it technically not possible at all? Answer is no, it is possible. Is it making sense or not really? Yeah?
Yeah.
Bhavish, are you with me? 100%. Ananya, Myra, Sana, Datta, everybody with me? So Surabhi, if I am scaring you in the first class itself, you are dealing with a very nosy teacher. What it means is, I check with everybody, okay? If I am teaching something to somebody, it is not about that one child who understood everything. It's about every child understanding the tiniest bit that I'm trying to explain. Okay? And obviously I rely on what you guys say, but I keep bugging people, okay? Is that okay?
Yeah.
Okay, fine. So we saw what is exactly log? What is that we, how do we relate log with something that we know already? So in the simplest form, if you want to think about log is nothing but an extension of our understanding of exponents. Okay? So as long as we understand what is exponent, relating that with log would be easier. Now the question is, why do we need to talk about log? Because it gives us more scientific way to calculate or deal with numbers with different base. Okay? Imagine a situation where you're trying to find out what will be the value of 2025 with a base of 5. In the regular mathematical world, you will not find the relevance for this one. But when it comes to more scientific calculations, that is when you will see this. So logs are used extensively in the research space, where you change your base and see what power of this gives you this. Okay? And right now we'll just assume or believe that logs are used for scientific calculations, and when you guys get into that space gradually, 9th, 10th, 11th, 12th, when you start dealing with pre-calculus, little bit of calculus, and then you start dealing with more complicated mathematical operations, that is where you will see relevance of this, and a lot of things we will see as part of the practice. Is this right?
Sorry, I have another question.
Mm-hmm.
So, will an answer, can the answer result in a decimal?
Yes, it can. Very well, right? Let's look at it. Let's look at examples, okay? And I'll give you guys some problems to solve. Let's say if I'm talking about log of 3 base 9. Okay? Meaning that equals, let's say, y, and we'll find out what is the value of y. So it can certainly result into a decimal. Now look at it. Here my base, when my base is bigger than the number that I'm trying to find the log for, it will give me a decimal. Why? Because, see, is this satisfying the condition? Yes, this number is greater than 0, it's a positive number, and my base is also greater than 1. So it satisfies the condition for log. Now, in this case, 9 to the power y will give you a 3. How? 9 to the power 1 by 2, or square root of 9 is what will give you 3. So that means this power 9, this y value is 1 by 2. Y is 1 by 2, which is nothing but 0.5. Possible? This value.
Yeah.
Make sense?
Yeah.
So simple correlation that you can draw always here is, if the number for which I am trying to find out the log is smaller than my base, there is a very very likely chance of getting a negative thing. Or a decimal, not negative thing, a decimal value. You can still get a decimal. Let's say if I'm talking about finding out log, my budget is going for a toss. All my markers are dying at the same time. Give me a second. So, decimal is a very common scenario, and I'll try giving you guys some example here. Let's say you are trying to find out log of 8 base 4. First scenario that we saw was that when my base was smaller than the number that for which we were trying to find out the log, we got a decimal. Now look at this situation. Log of 8 base 4 is how much? Let's say x. That means 4 to the power x equal to 8. We know that 4 to the power, there is no power to the x, to the 4 that can get me x, but I can get 4 into 2 as 8. Now this 4 is 4 to the power 1, and this 4 is nothing but square root of 4, which I can write as 4 to the power 1 by 2. Now when I multiply these two, it becomes, by the first rule of exponents, x to the power a times x to the power b becomes x to the power a plus b. So here 4 into 4 to the power 1 by 2 becomes 4 to the power 3 by 2. So this x is nothing but 3 to the power 3 by 2. So x is 3 by 2, which is 1.5. So you will not get the decimal only in case when your base is smaller than, bigger than the number. It can happen that when it's not a perfect power of the base, you can still get a decimal. And that's a very common scenario. Make sense? Yes, sorry.
I don't get how actually you got 3.
Okay. So let me relate to it. Anyone in the class who is still grappling with it? I mean, I'm going to explain it any which way, but I'm just trying to check the water level here. Everybody, yes or no?
I'm still a little confused, but I think if I do practice, I can.
Okay. So, say it one more time, better. Last statement I missed.
I think if I do some practice, I can figure it out.
That you will figure out. But in the class also, don't be shy. Just say, okay, sir, can you explain one more time? That's okay. That's what we're here for. Yeah? Okay, Vasundhara, are you with me so far? Vasundhara doesn't want to talk to me. How about Ananya? Are you with me so far? Ananya, Nika, Bhavish, everybody okay? Okay. So here, what we are trying to find out is, so okay, let me give both examples. Before I go into this one, right? Since it has a very strong bond with exponents concept, so I will just touch upon that real quick. If I am talking about x square, what I am talking about? X into x, correct? If I am talking about x to the power 1 by 2, what I am talking about? I am talking about x to the power square root of x. Okay? If I am talking about x to the power 1 by 3, what I am talking about? I am talking about cube root of x. Is that a fair point? Everybody with me? Yeah? Bhavish, Myra, Ananya, everybody? Okay. So, this is the understanding, I'm just keeping it here, okay? Now, let's go to first scenario that I was talking about. If I'm trying to find out log of 3 base 9, and how much is that? Whatever we don't know, we'll put a value of x. Not the same x. Let's say, let me be a little more, what do you call? There's a term. Self-obsessed. Let me be self-obsessed and say this is equal to b. I'm using my first letter of my name. Okay. So log of 3 base 9 is b. So based on our understanding of log, it means 9 to the power b is equal to 3. Right? That's how I'll read it. Sana, this all everybody with me? If so, the name is with me. So, okay. Alright. So 9 to the power b is 3. Now how much has to be b to get me a 3? We know that 9 is nothing but 3 square. So if I do a square root of this, I will get a 3. Meaning 9 to the power 1 by 2, 9 to the power 1 by 2 will give me a 3. So this b is nothing but 1 by 2. Does that sound okay? Sana, Surabhi, Anika, everybody? Okay. So now this 1 by 2 is my b. So that means I can get log of any number as decimal, which is possible. And that happened when the number for which I was trying to find out the log was smaller than the base. This was the first scenario. Yeah? Sana, okay, beta, conceptually? Yeah? I mean, while I certainly want to see you guys do more practice, and I would never ever ask you guys not to do practice, because practice is the key, regardless of how good, bad, ugly, horrible teacher I am. But at least from a concept point of view, you should not have any doubt. So this is one scenario. Now the second scenario that I was talking about was, let's say If I am trying to find out log of 27 base 9. Okay? Here this number is bigger than this. So that this is not going to be the reason for the decimal, but 9 to any power, any perfect natural number, power as a natural number is not going to give me 27. Let's figure it out. Let's say this is y. So 9 to the power y will give me 27. Now 9 to the power y will give me 27. But 27 I can write as what? 9 into 3. And this 3, since I'm talking about 9 to the power, so this is 9. This is not 9. But I can write 3 as square root of 3 I can write as square root of 9. Yeah? Is everybody with me?
Yeah.
Now this 9, and I can represent the square root in another way like this. So this is called the radical exponent form. This is called the rational exponent form. Both are the same thing. Yeah? Same curry with two different spices. That's it. So here, now I'm looking at a situation where I have two 9s getting multiplied with each other. One with a power of 1, other with a power of 1 by 2. If you relate that with the first rule of exponent, which says x to the power a times x to the power b equals x to the power a plus b. So here this is a x, this is power a, this is x power b. It will become x to the power, or that is 9 to the power a plus b, which will be 9 to the power 3 over 2. That means this 3 by 2 is equal to y, or y equal to 3 by 2, which translates to 1.5. Did I do a little better job this time? Sana, Ananya, Anika? Yeah? Disali seems convinced. Sana, is that making sense better?
Yeah.
Yeah. So again, see, while as I said, you guys will do practice, and that is the key. But then, at least from building the basic construct or the concept, as far as that is concerned, we should muddle the water in the classroom itself. Okay? Don't think that no, you will do it later. So this is one unique thing that I'm trying to practice here. Okay? In my classes, every class, every grade, every child, okay, is when we are in the class, if there is a doubt with any concept, get it clarified in the class. Many places, when kids go, I mean, I'm sure you guys have studied elsewhere also somewhere. I know that they will teach you something, they will give you assignment and then just do it. And many times I've heard from parents saying, okay, my kid brings assignment from home, from school or from their classes, and then we end up doing it. I never prescribe that. I will say, if I am giving you guys assignment, do it by yourself, don't bother your parents. If something you are not able to do, it's not because of you, it's because of the teacher. Teacher did not teach it right. Can I tell the teacher again in the next class, say, okay sir, you explained something, I don't think I got it, can you explain one more time? So that's the reason why I give assignments. So Surbi, if you are not aware, I do give assignments. My assignments are not scary. Okay? I'll give a little bit of assignment just so that you guys can practice it to ascertain that yes, whatever you learned, you are able to apply that. Yeah?
Okay.
Okay. Now a moment of silence. Let me check with everybody. Mr. Bhavish, Anika, Ananya, Myra, Vasundhara, everybody okay? Did I do an okay job so far or not? Datta okay? Yeah? Alright. So, it's time for moving on to do some practice. Okay? Your teacher doing some problem here is not good enough. I would want you guys to get your hands dirty as well. So for Surbi, every teacher has a punchline. My punchline is, I love dirty hands. Meaning I want to get your hands dirty as well. So I will give some problems and I would want to see how you guys are approaching that. Okay?
Okay.
So let me find out where I have kept some problems for you guys. I have put some really stupid simple problems that I could get from Khan Academy. So I want you guys to find out log of 64 base 4. That is one problem. Second one is find out log of 512 okay, no, let me not get lost in these numbers. Find out log of 32 base 4 and find out log of 18 base I'm just thinking, how do I get you guys troubled a little bit more? -27 base -3. I want you guys to try these three flavors of finding out log. Log 464, log 432. I mean, basically you have to find out the value of log of 64 base 4, log of 32 base 4, and then log of 27 base -3. Let's see what happens. And when I was looking at the some sample problems in Khan Academy for this particular topic, the questions that I got were much easier than what I put on the table, because the concept that we looked at, those are a little more interesting. So I want you guys to try dealing with these ones so that all the speech that I've given, you're able to make use of it. So time for me to be muted. Everybody got the question right? Surbi, Dishali, Anika, Bhavish, Myra, Vasundhara, Sana, Nanya, Datta?
Yeah.
Okay, go for it. If are you able to try better?
Yeah.
Okay. Yes, Shariyai.
So for the first one, I got 3.
Okay.
And then the second one, I got 2.5, and I'm still doing the third one.
Okay. Alright. Take your time, finish it, and then we'll stop. Bobby, what's going on there? Working on it? Bhavish, Aryahi, is everybody trying? Or is everybody crying? Hmm? No response? How about Vasundhara? Ananya? Are you typing it up? Sana? Maya? Okay. Yes. Ready? Okay. Let's see. We will see.
So, is the one on the bottom like? Is it one number one? Is it the one on the bottom like numerator or top?
No, it's not numerator, it's called base.
Oh.
So you're trying to find out the value of log of 64 base 4.
Okay.
So if you're trying, let's say somebody says find out log of 64 base 10. So 10 to the power something will give you 64.
Oh.
Here,
Okay.
yeah.
Okay.
Yeah. So Ruby, how are things going right now?
I'm almost done with the last question.
Okay. Let's see. You say, what did you get?
Sir, I don't understand the last two.
Okay. Don't worry about it. I'm here. I'm just trying to wait for, rather I'm going to enjoy everybody's struggle for a little bit more, then we'll do it. Alright. Now kids are worried about me. Yes, Sana, go ahead. Rita.
I got 3 for the first one.
Okay. 3 for the first one. How about the other ones? You still working on it?
I'm almost done with number 3 and I don't know what to do for number 2.
Okay, we'll see. Try till the time you can, and then I will jump onto it in a little bit. Okay, Dishali, what did you get?
I got 3 for the first one, and I don't know how to solve for the third one too.
Okay. Let's see.
For the first one, I got 3.
First one you got 3. Okay. How about the other 2?
For the second one, I didn't really quite figure it out.
Okay.
Because 4 to the power of 2 is 16. 16 to the power of 2 is like a long number. So, wait, no. So, wait.
I think I'm making you think right now.
Yeah, but it's like a bigger number. So,
Okay.
yeah, that's fine.
Myra, what did you get?
I got 3 for the first one. I don't understand the second and the third one.
Okay. Alright, so my job is getting difficult now. Okay? Fine. I have to talk about these one more time. Okay, so now what did you get?
I got 2.5 for number 2.
2.5 for number 2. Okay. Now, since we have only 5 minutes left for the class, so I will use those 5 minutes effectively to try solving it. Yes, Vasundhara, tell me your answer better, then I'll jump onto it. Uh-huh. Okay. Okay. Maya, you want to add something real quick?
For the second one I got 2.5, for the third one I got 3 also.
Okay. So now it's my turn. Okay. So I will try doing that the simplest possible way. Okay. Everybody just look at me. I mean, look at me as you look at the board. Okay. Second one was log 432. So I'm trading some real estate here. My recommendation, request, prescription, whatever you call it, is that always look at problems in a very simple way. Whatever you are trying to do, I'm sure whoever has got the right answer or has got something would have followed some approach. For me, it's always what I don't know, I'll give a name. And I'll go back to my basic understanding of logarithm. If this is what we have to find out, and I don't know what exactly it is, I am giving a value of x. Now I'm going by the definition of log, which says base to the power this will give me this. Meaning 4 to the power x will give me 64. Now 64 is nothing but 4 into 4 into 4. That is 64. So that is 4 to the power 3. So 4 to the power x is equal to 4 to the power 3. That means I am talking about x equal to 3. No questions about it. So you guys got it right. Okay. Now same thing. I don't change my stance when it comes to solving different problems. My approach doesn't change no matter whether my numbers change or not. So I'll follow the same approach here also. Log of 32 base 4. Okay, that will be equal to, let's say, x again. Going by the definition of log, it says 4 to the power of x is equal to 32. That's what it is. Base to the power this will be 32. Now 32 I can write as what? 4 times 4 is 16 times 2. And if I see here, I have 4 to the power x, meaning can I convert this guy also into the power of 4? Answer is yes. 4 into 4, and 2 is nothing but square root of 4. Yeah? If sir, is that okay with that? So that is 4 into 4 into 4 to the power 1 by 2. Square root 4 is nothing but 1 by 2. Is everybody following me so far? Whoever had doubt should be following me, right? Anika, Datta, Bhavish, everybody. Yep, bless you. So here, this is 4 to the power 1 into 4 to the power 1 into 4 to the power 1 by 2. That makes it 4 to the power, if you multiply these two, x to the power a into x to the power b, x to the power a plus b, 4 to the power 2, plus 4 to the power 1 by 2. Again you multiply, sorry, that is not plus, multiply. This became 4 to the power 2, and then you are multiplying with this. So 4 to the power 2 into 4 to the power 1 by 2, that will add up to become 4 to the power 2 plus 1 by 2, which is nothing but 4 to the power 2.5 or 5 by 2, whatever it is. So your value of x is nothing but 2.5. Yep. Arya, did that make sense, Buddha?
Yes, sir.
Okay. Now let's go to the third one. And again, I was trying to do some stunt with this. I was trying to defy the basic concept of logarithm by choosing a base which is negative. And I was trying to see if practically this is possible or not. Doesn't matter whether it's possible, not possible, I will go with my same basic understanding. And I'm trying to see whatever Sundara said, is that something in line with how I would look at it as well. So, going by the log definition, it is minus 3 to the power x equals 27. Now, 27 is what? 3 into 3 into 3. If I get any power of minus 3, will I ever get a positive 27? If I was talking about 9, then that was still possible because minus 3 into minus 3 gives me 9. But when I am talking about 27, 3 3 times 3 getting multiplied, it is not going to be matching with this scenario. Okay. So this negative power thing, negative base thing works only when you're talking about even scenarios. Odd ones will not work. That is why, as a generic rule, it is not given as a guideline that you can have a base as a negative. Okay. Whatever we did in the class, that was just to see if the same approach can be followed. Yes, Ariya?
Sir, could you repeat the last part again?
So what I'm saying here is, this one we are trying to solve, right? 27 base minus 3. And we are trying to see if that is possible or not. So minus 3 to the power x will be 27, correct? Going by the basic definition or understanding of log. Now, minus 3, if I do minus 3 to the power 1, I am getting minus 3. If I do minus 3 to the power 2, I am getting minus 3 into minus 3, which translates to 9. When I am doing minus 3 to the power 3, I am getting minus 3 into minus 3 into minus 3. So these two will get me 9 plus 9 into minus 3. That gives me minus 27. I cannot get a plus 27 here. So this is not possible. Okay, that's what Vasundhara was saying. So what I was trying to relate or confirm here was that this minus base is not a recommended thing for logs. Though you could still have some scenarios where you will still be able to find the value of a log with a base of negative value, but that only happens when you are talking about a positive power. Okay, when you have power like here, if it was 2, meaning that we have to find out for 9, when it's minus 3 to the power 2, that could work. But anything which gives you an odd power, that would not work. So you would, for all practical purposes, you would not want to deal with a log with a negative base. That's what I was trying to say. Yeah? Does it make sense? Anika, Dishali, Bhavish, Datta, wasn't everybody okay? Should be okay? Okay, so if that is the case, there is no point wasting your time when you guys are already feeling hungry. Go enjoy your dinner. We'll talk again tomorrow. Bye bye. Bye bye. Bye bye. Bye bye.